Hello everyone, and welcome to this tutorial where we will see together what Blender's property editor allows us to do. It's about that panel, that editor that we already saw together on the user interface tutorial. And this editor brings together options and parameters of all kinds. So in order not to make a video that is too long and not to get lost, I will only show you what I find interesting to model miniatures for 3D printing. So first thing to note is that this editor is organized with different tabs. The number and type of tabs are not the same depending on the type of object selected. Here we have nothing selected and we have 7 tabs. These 7 tabs therefore bring together general or common parameters for our entire project. If I select one of the warrior's items, I have 6 new tabs that appear. And therefore in these 6 tabs we will find specific settings for this particular item. If I select these black lines, which represent the character's armature or in other words the rig we use to articulate and position the warrior, well, we also have a different configuration. So here we can make a little criticism of Blender's design, because there can be a lot of tabs. And these tabs are only represented by icons, which do not necessarily perfectly illustrate what they do. It would still be fine if we only had 3 or 4, but here there are more than 10 pictograms to remember, which is not easy. And above all, we cannot, as we can do with the left side panel, extend the panel to display the names of the tools. To get the name, you have to hover the icon with the mouse cursor for a few seconds. It's not very practical. So the first 6 tabs are about general settings. The first allows us to configure our tools, and therefore options we will find here change according to the tool we are using. And in fact we realize that all the properties of this tab are also displayed here. We find what we have already seen together, for example with the select circle, so the brush radius adjustment, and the new additive and subtractive selection modes. And with the Move tool, we find the drag menu, which allows you to choose what you want to do when you drag the mouse outside the gizmo. We also find the small option menu, which is also here, which allowed us in a previous tutorial to move the origin of an object. So here I talked for almost 1 minute to show you that you don't need to use the first tab, because everything you will find in this tab is also here or in this bar. The second tab concerns rendering, which does not interest us at all to make 3D printing. But sometimes when modeling it's nice to simulate the miniature's appearance once printed, or even to simulate the miniature once painted. So we will do a little tutorial on this subject, and in this tab, we will find 2 or 3 interesting options for simulating shadows and light. I'm not going to talk about the third tab, because here there is really nothing relevant for us, nor even the fourth, which concerns rendering for compositing, which is 100% about image production. Then the fifth tab, the Scene Properties tab, is interesting because here we can adjust the units, and that is very important for 3D printing. So as this topic requires taking a little time, I'll do a dedicated tutorial on unit setup, but remember it's happening here. I'm skipping the next 2 tabs that don't interest us at all, and then we'll start to talk about properties specifics to our selection with the Object Properties tab. There we find our global coordinates for each type of transformation and for each axis, so exactly what we have already seen in the Item tab with the Transform panel. This is showing that the properties of this tab are specific to the object that we have in this selection. I'm not going to explain to you what relations and collections are. It's a little too early to explain now, but I'll show you its inside viewport display section. Here we can do things like display the name of the object. It can be very practical when we start to have a lot of objects in a scene. We can display objects wireframes to inspect topology, and with the in front checkbox, we can ask Blender to always display the object above the others, even if it is located behind another object. It's look like that. It's a little disturbing, but it can be very practical to focus on a particular object. This is why the black lines of the armature are fully visible. This part of the circle goes behind the hips and should be hidden. I activated the in front option for the armature because, when you pose a character, it's better if we can see the joints hidden behind other objects. But I can disable this option, and it goes back to normal. We can also choose the color of an object to differentiate it from the others, but for that to work we have to go to this menu, the shading menu, and tell Blender to display the object's color instead of a generic color. We'll talk about this menu later, but I'll just quickly show you the random option, which apply a random color to each object. Very useful for clearly differentiating all the objects in a complex scene. Then we have the Modifiers tab. There, you will see, it starts to be more fun. There are a lot of modifiers that allow you to do a lot of things. I'm not going to explain them all. By the way, I don't even know all of them myself. But we will use some of them in next tutorials, so I'm going to show you the principle. For that we will create a very simple object, like a small cube. I will show you later how to create objects. Then I will add a modifier, for example, a subdivision modifier. We can see that this modifier subdivides and smooths our object. And we can add as many modifiers as we want. They will be stacked and applied one after the other. There we will add, for example, a wireframe modifier. The wireframe modifier will somehow solidify our mesh, so the segments will become solids, like wires, and the faces will disappear. And we can adjust the thickness of the wires here. And then, let's see what we can add. Here, I'll add a simple deform modifier. So as its name suggests, this modifier allows us to make a simple deformation on an object. For instance, let's choose bend mode so we can twist our cube like that. Note that modifiers are applied in the order they are stacked. If I change the order, like putting the wireframe before the subdivision, it gives us this. I'll turn off the display of modifiers to show you what's going on. So to disable a modifier, we use the little icon that looks like a screen. So initially, we have the cube which is not yet subdivided or anything else, and therefore we only have 12 edges. Then I apply the wireframe, so only these 12 edges are turned to wire. Then, I activate the subdivision modifier. But this time we no longer subdivide our cube because it's no longer a cube, but rather a kind of cage. And finally, if I activate the deformation modifier, we twist the object. Let me show you a last nice modifier, which we're going to use a lot, the Boolean modifier. The Boolean modifier is an operation of subtraction, intersection, or union between two objects called operators. So what we are going to do is delete all modifiers on this cube, which will be our first operator. Then we are going to create the second operator, which will be a small sphere. Let's slightly move it into the cube. Then go back to our cube and add a Boolean modifier from the list. We then pick the second operator with the eyedropper. And there, well, nothing seemed to happen. It's because the sphere has dug a hole in the cube. But since the sphere is located exactly at the location of the hole, it hides it. So what we are going to do is move to Object Property tab and in Viewport Display, put our object in front, so Blender will display as the cube on top of any other objects. And there we can see that we dug a hole. So the Boolean is nice, but it requires a lot of resources. To enable a modifier, we check this button called Real-Time Display. It means that Blender calculates, or rather our PC calculates, the modifier's effects in real time. If I move one of the two operators, Blender dig a new hole more than 50 times per second. So it's okay, it doesn't slow down, but with more complex geometry, Blender could only dig the hole about 10 times per second, which is very slow. So most of the time, if we are sure we want the operation to be definitive, if there is no reason to go back, we can apply the modifier here, and now our PC will no longer calculate a new hole in real time, and so we can remove the second operator. That's all for modifiers. We're going to skip the tabs about particles and physics, which are used to simulate fluids or gravity. It's a little too advanced for the moment, and then we will talk a little bit about constraints. These tools are more for animation, but we use constraints to create a rig, so I'll show you an example. Constraints, as their name suggests, are used to limit or force an object to do a certain type of transformation. For example, we can say that a leash is a constraint which prevents a dog from moving more than a certain distance. The equivalent here is the constraint called limit distance. So we're going to say that this cube is the dog's owner, the one who holds the leash. And to create the dog, we duplicate the first object with Shift+D and put it a little further, and there we have our dog. Next, in Constraints tab, I add a limit distance constraint on the dog. Then I choose the owner with the eyedropper. And let's say that the length of the leash is 70 millimeters. So now I'm free to move my dog object, but never more than 70 millimeters from the owner, and you can see the little blue line that could represent the leash. There is other constraints, which takes almost total control of an object. That is to say that we no longer be able to manually transform, move, rotate, or scale the constrained object. For example, the Track 2 constraint forces an object to orient itself according to the position of another object, as if it were following it with its gaze. So we're going to make the owner always watching his dog. I select the owner and add a Track 2 constraint on it, and we can select the target with this eyedropper. And now when I move the dog within the limit of the leash length, the owner will always orient itself towards his dog. Note that the rotation values do not change. Here the rotation values for the owner are 0, 0, 0. And if we move the dog again, the owner is clearly rotating. But if I go back to the owner's transform values, the XYZ rotation values are still 0. And if I want to orient the cube by hand with the rotation tool, or directly with the values here, nothing happens. The rotation XYZ values of the object are completely substituted by the constraint. As with the modifiers, I can toggle the constraint on or off by clicking on the little eye, and there the rotation XYZ values take over. Then let's move on the Data Properties Objects tab. Here we can find properties according to the type of object selected. Here our object is a mesh, and to tell the truth, for now there is not much interesting things for this type of object. If I select the armature, we will have different properties in this tab. The pictogram changed, but it's still the Data Properties Objects tab. Then we have the Materials tab. I will not linger on it for the moment, because we will talk about materials in another tutorial where I will explain how to simulate the appearance and color of a 3D Mini. And finally, the last tab concerns the textures. We are not going to talk about it. This is absolutely not the subject of this series of tutorials. And that's it! We've done the trick. The idea here was not to teach you how to use all these properties, but to give you some landmarks, so that later when I refer to such and such properties, you'll know what I'm talking about. Thank you for following this tutorial, and see you soon.